Chapter 3, Numerical Summaries of Center and Variation. In this chapter, we're going to look at different measures of center and spread. For symmetric distributions, we'll be looking at the mean and standard deviation, while for skewed distributions, we're going to be looking at the median and the interquartile range. To measure variation, we're going to talk about variance and the range. Then we'll move on to the empirical rule and z-scores for symmetric distributions. We'll talk about box plots as a way of displaying a measure of centers and spread by using the 5-number summary. We'll talk about outliers, and then we'll talk about comparing distributions. In this video, we're going to start with symmetric distributions. Now remember, when you're dealing with numerical data, we've talked about how to display the data. The next step is to provide some sort of numerical summary about the shape, center, and spread of the data. In Chapter 3, that's what we'll be looking at, the center and spread. So let's start with center. If your data is, especially if your data is symmetric, the mean is what we want to use to measure center. You can think of the mean as the balancing point of the distribution. Now this is probably a formula that you've seen before. If I have a set of observations, to find the mean, I'm going to add them all up and then divide by the total number of observations. So suppose I have exam scores for 2 different classes of Math 111. What's the mean score for Class A? Well, I'm going to add all of these scores up, and then I'm going to divide by 9, since there were 9 students in the class, to get a mean of 78.89. What about Class B? You should pause the video and try to compute this mean on your own, and then come back and check your answer. Okay, so hopefully you pulled out your calculator and added up all of the numbers that were in Class B and divided by 12 here, since there were 12 students, to get a mean of 81.083. Now, if you're using the Desmos calculator, you can also calculate the mean by just typing in mean. And in this case, I copied all of the numbers. I'm going to put them in as a list separated by commas, and that'll calculate the mean for you. The mean was 81.08. Here's a dot plot of the distribution of ACT scores for a sample of statistics students. Now notice this distribution is symmetric, and the mean is very close to the middle of the distribution here. In symmetric distribution, the mean is a good representative of a typical value of your data set. Here's a histogram of salaries in millions of dollars for professional baseball players in 2010. Does the mean look like a good representation of the typical baseball salary for that year? Well, in this case, this data is skewed to the right? The spread is further to the right. And so the typical value is more over here than over here. The mean is pulled in the direction of the skew. It's affected by these large values that are spread out over here. So in this case, the mean is not a great representation of the typical baseball salary in 2010. So when do we use the mean to describe our typical value? When our data is roughly symmetric, it's appropriate to use the mean. If your data is skewed, the mean is not a good estimate of a typical value. And we'll talk about a better estimate for the typical value in a few sections.